Okay, so this is chapter 4, some of the examples that we've done in class. And I'm just going to make a bunch of videos covering these examples. So in this one, let's look at example 1 here. We got a wheel of radius 2 feet, centers at the origin, and then there's a paint spot on the rim of the wheel. They would be at 2, 0. So if we draw a picture of this thing, I'm going to use black for the main parts. So it's centered at the origin, so that's 0, 0. Radius is 2, so here's our wheel. Right? Radius is 2, and there's a paint spot right here at 2, 0. So that red dot's the paint spot. And then the wheel is spun 110 degrees counterclockwise. So let's see, this paint spot would get moved. There's 90 degrees, so it's a little bit further than that, to about here. And the amount that we spun it was 110 degrees. Okay, so the first question is, what are the coordinates of the paint spot? I don't know why I said in part A. It is part A. So whatever. All right, so this is xy. Okay, so we need to figure out what xy is. And remember that we can use trig now to help us. If I know what theta is, which I do, it's 110, but let me write out the definition of sine theta. That's the y value over the r value, and cos theta is the x value over the r value. So then this means that if I multiply both sides by r, I get r sine theta equals y, and I get r cos theta equals x. So then x comma y equals r cos theta, r sine theta. Okay, and in this case, theta is 110, and the radius is 2. So all I got to do is plug it in, 2 cos 110, and in this case, remember it's degrees, and 2 sine 110 degrees. And you can plug that into your calculator. Just make sure when you plug it in to check your mode, you want to make sure you're in degree mode and not radian mode. Otherwise, you might get some weird looking answers. So if you plug this in properly, you get about negative 0.684 and 1.879. And if you look at the picture, radius is 2. This is pretty close to 2. Well, it's 1.879, and then I got to go backwards a little bit, negative 0.684. So this seems like a reasonable answer. The next part B, says, how long is the path covered by the paint spot as the wheel is rotated? So in other words, I'm asking how long is this dotted line that traces out the path of the paint spot. So if I call that L, then we can set up a proportion. So here's part A. Part B, if I say the angle that I carved out was 110 degrees, and that was out of 360 total degrees. So that's the percentage of the circle that I've rotated by. And the arc that it carved out, L, is part of the entire circle's circumference, 2 pi r, which is 2 pi times 2. So if you do a little bit of algebra on this stuff, or cross multiplying and simplifying, you end up with 440 pi over 360 equals L. And then you can simplify that some more. It becomes 11 pi over 9 equals L. And 11 pi over 9 feet doesn't make too much sense to people in general, so let's turn that into a decimal. It's 3.8397, roughly, feet. So there we go. Okay, so that's part B. And then C says, do part B again, but now use 3 radians. By the way, 3 radians is not the same as 110 degrees, so don't just think we're solving the same problem here. So just use 3 radians for our rotation. So in this case, we've got our circle, radius 2, and so radius 2. And I'm spinning from this point around 3 radians. And remember, there are 2 pi radians in a circle. So over here is pi radians. That's about 3.14. So I'm going to be a little bit less than that when I rotate around here. So let me use a different color. So, whoa. Here's the amount that I'm rotating by. Right here. So this angle is 3 radians. Okay. So if I set up a proportion like I did in B, I've got 3 radians out of a total of 2 pi radians in the circle. And that's going to be my arc length, which I'll call L again, over the full arc length of the circle, which is the circumference, 2 pi r. And before I work anything out, well, I'm dividing by 2 pi in both cases, so if I multiplied both sides by 2 pi, those go away. And then this turns into, when I cross multiply, 3 times 2 equals L times 1. So 3 times 2 equals L. So 6 feet is my arc length. Now, I want to mention why this is called radians. So a radian is if I took this one radius right here. So let me do this in a different let me do a different color altogether. So first put this back. If I took one radius right here, right, and instead, oh, jeez. Okay, there's my radius. And I'd take that radius, r, and I wrap it around this circle, r units, right? So that's one radius right here in arc length. Well, the reason that the angle is called a radian, this is 1 radian. It's the angle size that's carved out by 1 radius as you wrap it around the circle. So as I go around 2 radii, 3 radii, remember there's pi radii in the first half of the circle, so there's a little bit left over right here. And then I could do it again, 1, 2, 3, and a little bit left over there. Well, remember we rotated by 3 radii, or 3 radians. So here's 1 radian, here's 2 radians, here's 3 radians. That's 1r, 2r, 3r, and remember r was 2. It was 2, 4, 6, right? 6 feet. So you can do it that way when the numbers work out nicely and you're working with radians. So, okay, so I'm going to stop there. Then I'll do the next 2 or 3 examples in one video because they're relatively quick. All right, I hope that helps.